2017, paper 2, question 4, the circle. So in question 4, we're given 3 points on a circle and we're asked to find the equation of the circle. So as always, we do a little sketch so we can give a rough idea of what we have and what we need to find. So when we want to find the equation of the circle, what we need is our centre and our radius. And if it's not an easy way to find it, then what we do is we do our algebra way and we try and find minus g and minus f. In other words, we try and find g, f and c, which will allow us then to find the radius and the centre. So what we do is we take the general equation of a circle, which can be found from our maths tables on page 19. And the general equation for the circle is x squared plus y squared plus 2gx plus 2fy plus c. And what we're going to do then is all three of these points lie on the circle, therefore they must satisfy the equation. So if I start with point A, which is 0, 0, that means if I sub it into the equation for x and y, it will satisfy it. So in other words, the left is equal to the right. And therefore that leaves us with c is equal to 0. So we've already found c. Now all we need to do is find g and f. So we're going to take our second point, B, which is 6.50. And then again we sub in for x, sub in for y, plus c is equal to 0. And we have 6.5 squared is 42.25. And 2 times 6.5 is 13g. And of course c we know is 0. So therefore that leaves us with 13g equals minus 42.25. And therefore g is equal to minus 3.25. So now we have c and we have g. Whereas normally in this type of a question we would get 3 equations in terms of g, f and c. Here, because of all of our zeros appearing in these coordinates, it's making it nice and easy for us. So our third point was c, 10, 7. So again, if I sub in for x and y, we have 10 squared plus y squared plus 2g times x plus 2f times y plus c is equal to 0. And again, I can sub in for g and I can sub in for c here, which would allow me to find f straight away. So we have 10 squared, which is 100, 7 squared, which is 49, plus 20g. We know, 20g, but we know that g is minus 3.25. Plus 14f and c is 0. So therefore if I simplify that, that gives me 14f is equal to minus 84, and therefore f is equal to minus 6. So now all I have to do is go back and sub it into the equation of the circle to finish off for g, f and c. And therefore I have x squared plus y squared plus 2 times g x plus 2 times f y plus c, which is 0 is equal to 0. And therefore my circle, if I multiply across there by 2, I can eliminate that fraction. And we end up with 2x squared plus 2y squared minus 13x minus 24y is equal to 0. And we had 10 marks going for that. It's broken down into 4 parts. So D. So we have 3, 5, 8 and 10. Okay, so for B, it asks us to find the angle BCA. We have to give our answer in degrees and we have to find a correct 2 decimal places. So again, making sure that our calculator will be in degrees here and always writing it in the correct format. So angle BCA, well basically if I join my points on my circle there, what you can see is I'm going to form a triangle. So BCA is this angle up here, theta. So we can clearly see it's an acute angle. Okay, so what I'm going to do is I'm going to find A to C's slope, and I'm going to find B to C's slope, and I'm going to use the angle between two lines, which is tan theta is equal to plus or minus m1 minus m2 over 1 plus m1 m2. Now you could of course find the distance between each of those points, so find AC, AB and BC's length, and you could use the cosine rule then either. So again, if we look at our maths tables, page 19, we can see at the top of page 19 there we have the angle between two lines is the equation here. So therefore, if I find the slope, so if I take A, 0, 0, and C is 10, 7. So if I use this one first, so I have x1, y1, x2, y2, then my slope, we know from page 18, is y2 minus y1 over x2 minus x1. So subbing in our values there, I'll call it m1, we have y2 minus y1 over x2 minus x1. So m1 is 7 over 10. And then if I do the same for BC, B is 6.50 and C is 10, 7. I have x1, y1, x2, y2. So m2 is y2 minus y1 over x2 minus x1. And therefore m2 must be equal to 2. So now all I have to do is sub into my equation there. So we have tan theta is equal to plus or minus m1, 7 over 10, minus m2 over 1 plus m1 times m2. So that gives me tan theta. If I put that into my calculator, I get minus 13 over 24. So because I'm looking for the acute angle, I'm going to take the absolute value because obviously also terribly confusing. Tan is positive in the first, so acute, whereas tan is negative in the second, which would be the obtuse. So we're going to get minus 13 over 24 there. So 13 over 24. And if I get tan inverse on my calculators, making sure, as I said, in degrees, and correct to 2 decimal places, that gives us 28.44. And again, make sure you put in your degree symbol, include your units. So there was 15 marks going for this question. So we had 0, 6, 9, 9 and 15. And again, starring it because it had to be correct to 2 decimal places. So you would lose a mark if you haven't written it in correct to 2 decimal places.